What is DoubleZero? So I'm Austin Federa. I'm one of the 3 co-founders of the project. We have about 30 people working on it now between the labs and the foundation side of things. We announced in December of last year, and we're going to mainnet in less than 2 weeks. So pretty exciting to see. Yes. Thank you. So what are we building at DoubleZero? So we are building a new parallel internet optimized for high-performance distributed systems. And there's a lot of words in there. You've heard probably some pitches before about new internets and these sorts of things that people in blockchain are trying to build. The problem is a lot of those systems, the way they've approached it, is to build an overlay network, to build some type of software system operating on the same rails as the public internet, using the same cables, using the same pathways as the public internet, and add some flavor to make it faster. And to be fair, you can get some software optimizations on top of that. But fundamentally, what we're talking about here is if we want to compete with traditional finance, if we want to be able to really have things like incredibly fast pricing feeds, very fast execution, arbitrage that moves price discovery back on chain and takes it back from centralized exchanges, we have to be using the same types of base layer communications technologies that you see in the traditional markets, and specifically technologies that move faster than the public internet can do today. So what you see here on this graph is a version of what the DoubleZero network actually looks like. And so at its core, this project is about physical fiber cables in the ground and under the ocean. And this is what I mean when I say it's incredibly boring. We're talking about picks and shovel infrastructure. We're not talking about huge amounts of software infrastructure. It's a lot of software on top of it, but this is kind of the core of it, is if you want to make systems that are going to compete with TradFi in performance and execution, you have to strip away all of the stuff we've built on top of the internet and go back and say, what is the fundamental problem here? Well, we're using a steam engine and we have a lot better technology nowadays. So the internet wasn't built for blockchains. This should be kind of an obvious statement, but the fundamental model of the internet has always been one large server with many different clients coming out of it. This whole concept of P2P networks is not really what the internet was ever designed for. And today, most of the large companies that you think of as public internet companies don't actually use the public internet for most of how they move data around the world, whether it is YouTube, Google, Facebook, Cloudflare, Amazon, Microsoft, eBay. All of these companies have large private dedicated fiber networks that they run. They use the internet for last mile delivery, right? You're saying, what do you mean YouTube has a private fiber network? I watch YouTube on my phone. That's true, but the way they get the data to you before it gets to the cell tower is often over private dedicated connections because the public internet is not actually up to the task. This is the sort of evolution that almost every large tech company has gone through the course of its existence. They start off building a software-only product like Facebook, and then quickly they discover, you know what, we need more servers than we could just buy. So they start building their own data centers. First they build their own servers, then they build their own data centers, and now Facebook owns a huge number of data centers. And then they say, we really want to sell ads to people in the Philippines, but you know, the internet's not very good in the Philippines, so what do? We build our own subsea fiber cables. And today, Meta is one of the largest investors in subsea fiber of anywhere in the world, not out of the goodness of their heart, not because they want to make the internet a better place, but they want to sell you more ads. And the ads they can show you are directly dependent on how fast Instagram Reels load and Facebook Lives and all these other technologies. The same is true, weirdly, for a company like eBay. The same is absolutely true when you're looking at these companies like Jump and high-frequency trading firms, where their competitive edge comes from a lot of quantitative research and it comes from a lot of execution ability. But fundamentally, if you can be fast or you can be smart, you're going to pick fast every time. Because you can be smart and get stuff wrong. It's very hard to have information before someone else and make the wrong call. And so these companies have spent truly billions of dollars building out these private fiber networks, but they're all one-party systems, and all of these one-party systems are anti-network effect networks. So there's hundreds of different fiber networks that run all around the world. Many companies make use of these. Blockchain today, everything still runs over the public internet. And so we kind of have two approaches to this. There's the approach that Hyperliquid has taken, which Rob talked about earlier, which is we're just going to put everything in a single data center. And there's a lot of advantages of that. There's a lot of problems with that too. You're not able to follow market movements around the world because you're located in one data center. Additionally, you still have this problem of everyone racing to the same point. And if you are closer to that point than someone else, you have a faster connection into that point, you're gonna have a trade advantage over them. And it's not exactly the promise of Ethereum, right? The vision of this thing was not like, oh, let's put everything in one data center that stays in the same place. And that is basically NYSE, that is NASDAQ, that is Tokyo. Why are all the centralized exchanges in APAC have their servers in Tokyo? Well, it's because Binance is in Tokyo. And the further you get away from that, the more penalty you face. So with DoubleZero, we're building a purpose-built, dedicated high-performance network that's open and available to anyone who wants to use it and has multiple independent contributors. And that last part is really key. You've been able to build a private fiber network run by a single party for 30 years. It's what the Wall Street firms have been doing, and it's what many other companies have started doing. But all of these networks are anti-network effect networks. They're built for one purpose and one company, and they don't want anyone else operating on it. They also have no checks and balances. They have no ability for different contributors to monitor each other's usage and catch them misbehaving because, again, it's run in a traditional centralized form. So by using consortium models and token alignment, and this is the thing that crypto is better than anything else in the world at, you can bring parties together that normally would not be cooperating around problems to solve problems like how do you connect together 400 different data centers around the world with 100 gigabits of fiber to allow blockchain systems to move faster than they can over the public internet. So this is performance-first networking for a decentralized world. And this is really kind of important to focus on, is the internet today is basically run by 20 companies. You may think it's an open, expansive network where anyone can come in and engage with it. It's actually still a pretty closed system. And so with 12 network contributors to the DoubleZero network, we're about halfway there, which is pretty awesome for being less than a year old. But our whole purpose here is to open these systems up and make them more accessible. The same way that the revolution of the cloud was not really a technology model change, it was a business model change. Instead of saying, I'm going to call up a guy and order 40 servers and wait 3 weeks for them to get all racked up, you could show up to Amazon with a credit card and get fast servers in a lot of different locations in the world. And part of our goal with DoubleZero is to bring that kind of on-demand private networking connectivity to the blockchain world and beyond. So this is what happens inside of, we're going to get a little technical for here if it's all right. So this is what happens inside of something running the SVM today. So you have transactions coming in from a NIC. It goes through a whole series of signature verification blocks, which basically verify that the data is indeed correct. It goes through a fairly constrained operation called pack, where you pack a block based on however efficiently you want to pack it. It's then executed in the VM, and then it goes out the back of the computer again. This is the basic propagation process of building a block in a parallel architecture system. So raw transactions come in, they're built by one machine at a time, the leader schedule rotates, and this is what we see today in every blockchain in the world. There's no blockchain that lets you build blocks concurrently. There's also no network that has sort of a shared defense layer around these things today. So when we look at kind of how we change this architecture for DoubleZero to suit blockchains like Solana, Fogo, Aptos, Sui, all sorts of different networks, what we're really talking about is protecting the validator set from inbound data that would not be processed by that anyway. And so we have things like field programmable gate arrays in line with these systems that throw out duplicate transactions. They throw out transactions where the signatures don't verify. And this basically prevents the networks from being DDoSed in the way that they have been previously and helps them move along faster. And so this is kind of like a whole parallel internet architecture that we've built out here. And really, again, the goal of these systems is to allow blockchains to move faster than the public internet allows them to do. And so if you're looking at a network like Fogo, where you have things located in a few different regions and they move around the world, the handoffs there are really components that can be performance limiting, even if you're running stuff in one or two locations. The minute you have to move that to a new location, there's a whole data transmission problem that you run into with these types of systems. Additionally, just because the consensus group for a specific node set is quite performant and efficient doesn't mean that all the traders who need to receive data from that are connected to that system and have such high performance connections into it. This is a little counterintuitive because we think of things like NASDAQ as a global market and NYSE as a global market, but these are actually extremely local markets. They're localized to one data center in one corner of New Jersey. And when an event happens there, a price moves. That has to get propagated out. This is exactly the type of thing that Pyth is looking to solve. But pricing data is only one component when you're looking at a system. You need state for blockchains because you can't just trust the market, that the market is what it says it is. This is crypto after all. We have to verify stuff. And so I need to receive all of the block data to verify it myself, to run it, to make sure it is indeed correct before I send a transaction on. All of this type of stuff today is sent out through what's something called unicast. So it's one-to-one packets. It's if I am a validator that has 2,000 nodes that want to receive data from me, I have to send that out 2,000 times. That takes a long amount of time. Or we have to introduce other systems like Turbine, which create latency and state propagation. Instead, we can make use of multicast. And multicast, I'm not sure what that guy is. It's not from me. But I guess by a phone. But multicast is a totally different type of technology, and this is used by Wall Street firms all around the world, and also very common in centralized exchanges, where it's basically packet replication acceleration in hardware. So the validator or the data center only has to send the data once, and then the network switches automatically replicate it and move it around the world. If you're familiar with AirPlay or Chromecast, it's the same type of technology where your phone is able to send a stream of audio to 10 different speakers in your house as opposed to sending like 10 different copies of that stream out. And so these are kind of the two conceptual layers for DoubleZero. We have this filtration ring, which protects the validator systems inside from stuff that they wouldn't even process anyway. And then you have the execution ring, which runs on really fast fiber to connect data centers around the world. So you can have consensus happening in New York at the given moment, or then maybe it moves to Tokyo at another moment. But if you're running an indexer and you're running that indexer in San Francisco, because you're tracking lots of things happening on lots of different blockchains, you can continue to receive state updates through multicast irrespective of where consensus is happening. And you can receive it as fast as possible through the DoubleZero network. This is really important for traders. This is important for compliance. This is important for all types of systems. In TradFi, multicast is actually used to ensure compliance. So you will say, like, every time your server makes a trade, not only do you send that to the exchange, but you send it to a big compliance server run by the legal team to make sure that you have a copy to justify why you made that trade at any given moment. Without multicast, this would be a massive tax on execution for any of these types of compliance systems. So there's lots of different ways this technology goes into play, and lots of different ways that projects can actually implement it in the real world. DoubleZero, I wouldn't say we don't care about that, but it's not really up to us. This is base layer neutral infrastructure designed to accelerate all types of high performance distributed systems. And so we're really about giving a whole new tool set to protocol developers to build things that aren't currently possible to build. This is effectively what this looks like at a high level. You have different validators in different data centers connected through high performance fiber links to enable blockchains to move faster than the public internet allows you to. So this is kind of our vision of this. We want to bring the same type of high performance networking that companies like Jump and DRW and Tower Research spend hundreds of millions of dollars a year on, make that accessible to folks running validators and blockchains, to other types of high performance distributed systems, to change how storage systems work and actually enable folks like Aptos building Shelby to compete with the likes of Amazon S3 because they're not running on the public internet and governed by the rules and traffic routing policies of the public internet. So if it works, what is the goal here? Abundance. This is really like an abundance project to say that the decision to keep things arbitrarily constrained to a specific number is the wrong one. If we really want blockchain technology to proliferate throughout the world and truly compete with TradFi, we need to massively scale what these networks are capable of doing and the data availability that goes into them and the fairness that is currently missing from a lot of blockchain because of things like state propagation problems. And so, our goal here really is to support 10 blockchains doing 1 million transactions per second. And that is really what we would like to hold ourselves to, is to deliver those tools to protocol developers so they can vastly exceed what's possible today on the public internet. I think that's my last slide. Thanks.